Okay.
So, hello people of vvvv. Welcome here or today's tutor who will be Idwyr or Ekaterina Danilova. Sorry if I pronounce it weird or something. So, say hello.
Hi everyone.
So what will be today's workshop? How it will look like? If we can tell you, I don't know.
Oh, that would be a very, very beginner workshop for those who never wrote shaders before and want to start. So nothing super advanced, and if you are a bit experienced, this could be boring for you, so consider this.
Nice. All right, in this case. I kind of lost your audio feed. Okay, it came back. All right then. If you're ready, then we can start out immediately if you want.
Yeah, okay.
So, you're on stage now.
Oh, it's scary. So, first, I want to start with a very, very basic shader which displays only one color. The most confusing things about shaders is that it's data flow. It's not an array which you process every element one by one, and every pixel is processed in parallel. This could be confusing for people who are familiar with programming but not familiar with shading languages and shading. So here are our data structure for this shader. We have input. This is the position of our pixel, and we have only one variable output for it. It's its color. So for now we are not using UV map or anything. We're just outputting this one color, which we can set in the input of the pin. So, oh, it's here. And this is our color, and it's there. The output consists of a float4 variable, which stands for RGB and alpha channels. So we can modify it here. Just for you to see. And it's changed. So we have a separate access to every channel, and we have to modify it somehow if we want to see something else and not just a solid color. For this, we use one function which describes color for every pixel. So this is our function, and it's called here, and we see our pixels. So next thing is to introduce UV, the variable which can actually change anything in this code to see some difference. So we will try to make some patterns of it. So we see a circle, and here we have this semantics. It's a UV map of the texture. Let me show you the template for UV. This variable UV, this semantic, could be represented like this. So for its coordinates for every pixel we have in this texture. So it's x-axis and y-axis here is 0, 0 here, and 1 for x and 1 for y here. And you can clearly see it in colors if we just output its channels like colors. So we can create the patterns out of this. like this, we're creating a simple circle. Here we have a function which measures the distance for every pixel to the center. So if we have our coordinate system from 0 to 1, here and here, so this is our center, is 0.5 and 0.5 respectively, and we measure our distance. I should probably do this. So yeah, and we're multiplying our solid color by this distance. So we can see the color only in the very, very center, and it's fading to the edges. What it does here, it just clamps the value so we can see this nice circle. Like this, we can create simple patterns just to get familiar with this whole function thingy. And we can try something different. For example, we can draw a line. The line is made just with simple scene wave from the UV coordinates, UV map. We can animate it with variables, just connect this to the input, and now we have our moving line. Also, we can change the scale and color. And it could be very handy just to learn tweaking these parameters to understand what they stand for. And this could be nice to use it for a mask, for example. But it's later in our course. So I prepared several, like for you just to see that we can do absolutely everything with them. These are just several functions. You can look through them later or apply any weird math you want just to create random pattern. Here I have something a bit more crazy, like this. So you can use it everywhere, like procedural texture, and you can just change it on fly. For that one, I've changed code a bit to have background color and foreground color separately. And I'm using the interpolation function here to interpolate between them with this function we create here in this formula. And also, here's the one thing I want to mention. We use a UV map multiplied by matrix, which goes here. So it's a bit more flexible way to change it. Of course, we could hard code it, but I think it's a bit more flexible just to use it like this if we want it to be dynamic. And
We'd also note that never hard code that. So this is if you want to transform your UVs and you want to do it from CPU, you would need you're obliged to do it with the transform in the matrix transformation. Kind of.
Yeah, well, I've seen some guys just write transformation matrix inside the shader as a function, and for example, for creating like this pattern, and they have it like separate function here, a separate shader path. But for this workshop, it will be like this way from the bin.
Yeah, well, if there is some shader specific stuff which is controlled by the GPU, then it's all right. But yeah, okay. Just a note.
Oh, you can add notes, please. Correct me if I say something very stupid.
No, it's fine. It's fine.
Well, while preparing the workshop, I tried to remember how I first write my own shaders and how I started and what questions I had then. So probably maybe it's not the best deep knowledge of shader or language, but it's just a practical knowledge which helped me to proceed somehow, because it was really hard to begin. It's okay now, and I can just read some documentation and read about new render tech and just spend 3 days and maybe I will advance in it. But the very complicated thing for me was to start, because, yeah, as I mentioned before, the data flow is a bit unusual. So you have to just to be a bit more familiar with it. The parallel processing of every pixel. Of course, we use iteration loops and conditionals in this code later. But the most crucial thing of it is just to think of it as a data flow, and you have to understand that this function describes every pixel in parallel. So we just introduce some variables to it to modify pixels separately from each other. I hope these examples could be useful for understanding this very, very basic concept, because it's impossible to do anything else with shaders without understanding that. One friend of mine was confused about shaders and he couldn't write them at all because he was thinking of this code as some kind of description for an array, but it's not a description for an array, it's a description for every single pixel.
And we didn't even dive into all the P-line stages yet, so it can get more confusing with those as well.
Meaning?
It's like in the previous workshop I was covering a lot in the geometry and vertex shader and geometry shader and all the P-line stages of the tessellation, for example, and all of them kind of behaves in a different way. So you have to learn those differently, I guess.
Yeah, I think pixel shaders are the most easy to begin with. Yeah, because you can just manipulate the colors and see them immediately. So, and it's a big fun to just tweak the parameters and see the result. A bit easier with pixel shader. You can't broke a lot.
Oh yeah, indeed. Pixel shaders are very much more easier to comprehend than all the others to see the results immediately, because all the others kind of require you to match up semantics and match up the layout pattern of the geometry. So that's nasty stuff. You have to do it by hand. You have to do a lot of things by hand. So pixel shaders are very much more easier to comprehend.
Yeah, so now let's do some texture sampling just to show. Okay, now. Yeah, so we have our nice picture here. Oh, I guess I've lost the sound.
No, I can still hear you. Wait a second.
Okay. Yeah, it was lost for a minute. Okay, so we have our nice picture here. And what we do to display it is we sample it, because we have some texture file of whatever resolution, but we need to display it in maybe a different resolution. So its resolution is changing, you see it's stretching, and the way it's represented is called sampling. So it's sampled. And we have different ways to do this. I won't dive too deep into that because we don't really need it for this workshop, and it could be a bit more complicated. we have several types of sampling here. Let's downscale our texture just to see. So it will be more obvious. So the linear sampler, you see it's interpolating every sample, and the point sampler, it's sharp for every sample. So we don't interpolate between those two. It could be, yeah, of course you will need this. It's used everywhere, so just keep in mind. But for now, we will use just linear one, just for fun, for tweaking textures and creating patterns. Also, the very important thing is how texture is rescaled when it's smaller than your output. So if we downscale this, like we transform it and it's slower, it can behave different on its edges. It could be just clamped like this. So it's these pixels just stretched, and the default template, if you just open this, it's clamped. So sometimes you could forget about it, and it can ruin your shader and you won't understand what's going on, but you should always keep in mind those, and yeah, and just bringing you some attention. So the ROP sampler is just to multiply them, and you see it's pretty obvious like this if we transform texture. So it's replicated, and if you mirror it, it will be mirrored like this.
Well, the proper definition for this, though, is that when your UV coordinates are outside of the 0 to 1 range, then this enumeration, what you were changing, will instruct the video card how it would oversample, is that right? Over address your textures. So.
Yeah.
Just to mention it.
Yeah, we could scale UV manually in shader. Just, yeah. What am I changing here?
You want to put an equal sign after that?
Yep, second. Okay, so yeah, we don't have to use a transformation for that, but sometimes we can use anything instead of UV for UV, and we should keep in mind those clamp and other enumerations of sampler. We can also get rid of this and just uncomment this to have it hidden. So yeah, and if you want to change it from outside with this node, you should keep in mind that you don't need this one. Okay, that's it about sampling, I guess. Let's do some very basic blending. So if we have several textures, for example, 2 textures, and we want to interpolate between them and to blend them together. For this example, I'm not using anything complicated, just super basic interpolation without considering alpha and etc. And because you can see it in And here is a bit more complicated, is the way it should be. But I'm just showing very basics of it. So you have your textures sampled here, and we interpolate between them with this variable, just linearly, and you can see the texture is changing. No, it's, yes, this one. So yeah, you can see we're changing the texture this way. And also we can introduce some other operations, for example, addition and multiplying of color. So addition means that every pixel value is summed with next texture pixel value according to this variable. Yeah. And for example, if 2 pixels of these textures are white, we will have sum of 1 and 1 is 2. So it's really good to use clamp function for it, saturate, which clamps value from 0 to 1. So I don't use it for multiply because I think you can't really get, in this example, any weird numbers, so it's okay like this. So next thing I want to show is a mask. We have our 2 textures here, and we have in separate file we have a mask texture for this. So we can apply one texture through the mask on the other texture. And for now, we're just using the red channel of this mask as the opacity variable. Also, in some cases, maybe you want to use Luma coefficient for it. They look a bit different if you try. Well, it's not really obvious, but they look a bit different. So it's not only red channel. For perfectly monochrome texture is okay to use red channel, but maybe it's super colorful, and then you want to just use a luminance coefficient to blend through it. So, okay, what shall we do with this? We have the first shader I wrote was the color separation shader, just to understand a bit more about color channels and how are they represented here in this picture. So if we have our texture here, we can modify its channels independently using some kind of offset. So here offset is just a number, and we are shifting red channel to the left and blue channel to the right. And we're leaving green channel as it is. So the result will look like this. I guess most of you are familiar with this shader. It's doing more or less the same, except it has a lot of extras, but it's really hard to read through the code, so I made this very basic example just for clear understanding of the concept. Other thing that you can do is use some color buffers or any data buffers in shader. For this workshop, I've prepared some examples with color buffers, which you can use in shader. It's very handy to have some gradient texture like this. It's just an example because you can use this information for coloring for like coloring function for anything else, for some next more complicated steps or some patterns, which which go from 0 to 1, and you can color them like this with a gradient. And so we're iterating through this buffer and just taking every color according to our UV map and distributing them evenly.
I would also note for these kind of purposes, what you're doing here is that it's creating a cube-sized texture, but for gradients like that, it is absolutely okay to use a special type of texture called texture 1D, which is just like a row of these colors for gradients like this. So that's kind of an opinion about it.
Well, yeah, it's another way. Sometimes I use it too, but yeah.
Yeah, for these scenarios, it's okay for these simple scenarios. But if you have, for example, like 10 of these, then you might spare some resources on creating just texture 1Ds. The texture 1D is actually even faster to sample as well than 2D textures.
Yeah, so there's another example which uses this color buffer for colorizing, and also some data which can be like FFT data or some random spread or whatever to distort it in the texture. I like custom colors in aberration, so I just use some colors here and shift the texture, adding this color. Also, we have some distortion here, which we are getting through the displaced texture 1D, 2D, yeah. Maybe, yeah, it's nice to use 2D texture, just it's maybe not that fast, but sometimes it can be useful for creating these glitched patterns. So it's kind of weird hack which I use because we have this amount of elements, like 12 elements, and they're distributed for this resolution, and it could be a source of these patterns, which are nice. So yeah, most of my examples are super unoptimized and stupid, but it was fun creating them, and it's cool for beginners to just tweak like this. Still, it's a way to go.
These examples are all right. There's nothing.
Yeah, probably.
Nothing stupid about them.
Yeah, I think there's a lot of really non-optimal solutions for these examples, because when you try to create something weird looking, sometimes it's not that optimal, but for the artistic purpose you can do some weird hacks and misuse functions, for example, to create some nice results. For example, I like to misuse linear interpolation and give it some weird numbers like 6. It creates oversaturated pattern. For example, here, not pattern, but yeah, oversaturated texture. It could be useful sometimes. So it's not meant to be this way, but it looks nice, and sometimes you can use it in your code just to create this sort of overexposed image. The next thing I wanted to show is layering, which I use a lot. So if we have our pattern here, yeah, for example, this one, no. That looks better. We can use some functions and to just layer them inside the code. For example, here's the secret function which creates some glitched pixelized pattern, and we just stack them together, 3 of those, with different coefficients and different kinds. So we can add them, multiply them, and etc. Just to tweak these parameters to see if something is changing. And results could be very fun. Also, we can apply transformation for UVs separately for those. Scale one layer in X and other layer in Y, and just to create a pattern. Also, you can use just Perlin noise, which looks super nice combined in layers. And sometimes you can create some unusual patterns with it. Here, for example, you can tweak this noise to create this type of image. It's very easy and looks kind of familiar, right? So there's huge possibility on tweaking this type of image like this. We can adjust our layers. And create completely different image just in 2 seconds.
This is how you name. This is how you make. What was the publisher? Albanoto. Who was the? What was the publisher for the cover? Albanoto.
Yeah, right. Ikeda.
So yeah. That's like visuals like that. This is how you create them.
Yeah, like so. We can create them with 2 clicks.
Yeah.
Also, yeah, we can do like this, and really resembles his work, I guess.
Rasternoton.
So,
yeah, Rasternoton. That's what. Most of their visual related art is looking like that. So there you go.
So yeah, you have one shader and you can produce the whole show from it, I guess, in this minimal aesthetics. Okay, so another technique I wanted to show is displacement. It's super easy to displace something with UV. Just modifying UV, we can get really nice results. As a post-processing for shaders for some graphics, to make it more interactive, if we want to create something audio reactive, we prepared our scene where something is rotating, for example, and we want to be more obvious that it's a real-time thingy and it's responding to, for example, music. So let me just open the patch. Yeah, so we have our texture here, something, yeah, and FFT. I'll disable it for now because it's a bit annoying when it's moving constantly, but you can see we are displacing our texture with the data from FFT.
Yeah, try to turn on your sound if you have any. Let us see.
What?
Your computer. Oh, the computer sound is turned on already. All right, it's all right.
Yeah, it's okay. I just disable the FFT. Yeah, I don't want it to be active for the whole time.
Okay.
Yeah, because it's a bit hard to watch the animation all the time. And when I create a patch, usually first thing I create is a pause button for the whole animation to just pause it.
Yeah.
So here we go. We have our scene, and as a post-processing, we use a super simple displace shader, which takes data from 1D texture, FFT texture. Here we have it. It has data from FFT, or you can put a spread of numbers here to just modify it. What it does, it just I use a randomize function from this file. You have it in this shader, I guess. So it's in add-on pack. Oh no, not even, yeah, add-on pack. And I just copied it into my files and I use it. And here we're displacing with some noise values, which can be tweaked from, we have these variables to adjust power, the strength of this noise. You can use a MIDI controller to just control this and just switch it on when you want, very easily. And I think it's a nice effect, which can introduce some variety to the graphics, because you have your scenes and then you want to, it's super boring to look at this, like it's a nice scene but it's rotating and it's the same for the whole time, but you can just applying several post-processing effects like this, you can modify it into something completely different very easily. And just using parameters like this, you can produce super noisy variant of it and clear variant, and just switch between them very fast. So yeah, I prepared several examples like this. So here we have our graphics and the stretched line in the middle, which fits nicely. Yeah, just let me show the cursor. Where's my spectra? Yeah. Okay, so yeah, this stripe is controlled by the variable here. It's super simple shader, but it has a condition here. If our UV is not in the range, we just stretch the pixel, so we just take previous pixel color. And yeah, you can tweak this code just to see how the conditionals affect the image, and try some different options with it. Next example is a bit more, has a bit more extras. So here I use the mask. I like this type of patterns because I don't want my image to be completely trashed with this distortion or whatever. I want to use a mask just for thin lines here and there. And you can actually use a nice function inside the shader, but I prefer just to use external shader. Sometimes it could be more fast to adjust it this way, or to use anything as this mask, just another shader. So here we have this color space functions, which I use super often too. And For these parts of the texture are saturated differently and have different hue parameters, which we can tweak and change according to music and well, whatever. So yeah, it's nice to use this for some parts of image, just to create different colors over saturated colors. It's glitch aesthetics is very cool for beginner because you can create something cool with very simple code, and yeah.
You don't have to be afraid that you mess up anything. Because
What?
Well, in glitch aesthetics, you don't have to be afraid if you mess up anything. Because if you mess up anything, it is actually the part of the aesthetics.
Yeah, so it's very handy for beginner to start with glitch. You don't have to be scared of error because error is your purpose.
Yes.
And also sometimes computer can help you with your creative work. Actually, it did a lot with me. And so I had once some problems with writing textures too fast into memory, and there were a lot of unoptimized crazy shaders. So actually my glitch was glitched on top by the computer, and it looks even better this way. So yeah, maybe I'm going super fast with my examples, and yeah, I need to patch something online. It could take ages.
Oh well, compared to weekend workshop standards, your speed is just what you call it. It's very very pleasant, I guess, for people who watched weekend workshops recently. I mean, I'm super fast. So don't worry about that.
Yeah, I don't have that much examples. So we have to, I guess we will have to code something in real time.
Yeah, I do that all the time, so please do that as well. No, I don't. But I suggest to do that. Maybe people want to see how you code this from scratch, maybe.
Okay. I always find it super annoying when someone is typing very slow and okay, could you just uncomment ready file why you want to patch it to code it online? But okay. So,
well, that's live coding.
So okay, and last one, I just took the glitch, which is actually out there in the pack. Yeah, this one. Added some tweaks to make it audio reactive too. So we have our texture here. Yeah. And we have our FFT here, glitching some parts of the image, which could be nice to combine with any other effects. And yeah, we can just turn it. This one is very popular. I guess everyone is using it with RGB shift. Most popular effect ever. So yeah, and here I sample noise with this resolution, so it's only horizontal. But of course, we can do like this and like this. Okay, so next one, vast topic, feedback. So we have our pattern from the previous batch, which produces just circles. With simple feedback loop, we can create various effects like this. We're taking 2 frames, current frame and previous frame. using frame delay. Some people might say that it's bad practice, but very handy to use feedback in graphics for almost anything.
Well, feedback is actually used in more not useful, but more practical situations as well. Like you can't avoid frame delay, for example, for temporal filtered effects. Like there's one very famous temporal filter, ambient occlusion, or what else? Temporal anti-aliasing, for example, which I haven't seen to be implemented in vvvv, but that practice is actually not bad. It's just a thing. It can be used badly, but it is what you're doing is fine.
Yeah, okay. So you should be careful with feedback loops. Sometimes it can be broken, like this, and you have to reset it. Sometimes in 4V you can break the loop if you're just unconnecting effects from it. Well, I connect preview and it fixes somehow the loop, or reset, or connect node which is down next one, so not this one. It should not produce difference, but sometimes weird result can happen. So yeah, our feedback is a bit glitchy. You shouldn't be afraid of this. It's same glitches are in Touch Designer, I assure you. So feedback, what it does, we have two frames. We have our current frame and we have our delayed frame. And we modify one of them. So a frame which on the previous frame is modified somehow. Here we apply UV, and here we change it to UV a bit. Also, we change the hue parameters, and we make it a bit darker, because here I add our previous frame to the current frame. For creating this trail, a rainbow trail. So if I should make it darker, because if it's adding every frame, it's just begins to be very white. And you can do funny stuff like this. Feedback is very famous, and yeah, you can do a lot of interesting effects based on feedback. It's nice when it's not that obvious, because it's been overused, I guess. Now the history of feedback is long, because you can actually use feedback as pointing the camera to the television and make feedback like this, analog feedback. Okay, the next one, I just modified one I put in contributions a year ago. This probably you've seen some type of glitched images on the internet like this, so I thought it would be nice to provide some examples. What we're doing here we're getting white pixels, most bright pixels, and we're applying feedback on them. So yeah, just a second, got the cursor again. So yeah, you can see images non-modified here, but the brightest parts are being processed, and they're drowned like this. So here I just extract the offset for brightest pixels with Luma, and apply this offset only if a pixel is super bright. And my offset is like here, so I can change it. Be careful, because if value is too big, feedback will be looking badly. And yeah, the interpolation between current and next frame should be somewhere around almost 1. Because if it's 1, you just it loops on itself. It doesn't get any new information and gets overexposed, oversaturated, and etc. And if its value is too small, you just don't see a difference. So it should be somewhere around 0.95, 96. Yeah, also you can use different filters. Here we're filtering which pixels are being processed with this offset. Yeah, we can tweak this dynamically to see different results. Okay, so it's another example. Here I'm using the mask for, yeah, I'll just turn it away. This is our glitch, and we're applying it with mask only partly on the image. So mask fits the original texture. I just rotated it a bit to produce this nice effect, and yet our image is visible, original image is visible, and feedback's not getting that crazy, not getting oversaturated, and just the way I want it to be. So we can, this example, it has offset for every square, and offset direction changes every frame, just circular movement. And the direction is depending from this texture, just random texture. From 2 channels, from red and green channel, if I do it monochrome, the offset will be similar for X and Y. And the normal one is we have different offsets for X and Y, so it's offsetting previous frame in different directions and just creating this weird pattern. And we can change size of the pattern. And also, yeah, same parameters as in previous example. And this is flow multiplier. We just can change it to also, yeah, for feedback, it's crucial to have some modifiers after the original texture. Yeah, here it's a bit saturated after to create these effects. So it has some nice colors here because it's oversaturated here a bit. We'll added a bit of saturation and a bit of hue adjust. Okay, so next one. We need an example with our 3D scene. For example, we have a 3D scene. We have a box here. And on the background, we're sending our scene with a feedback effect. A very popular thing too. We can create a lot of images like this. We can modify our original scene, or also we can modify a UV for our feedback texture to create a lot of extra graphics like this. Oh, I see Chris on chat. That's embarrassing, Chris. Stop watching this video.
What? Who's embarrassing?
I see Chris M4D.
Ah. Oh well, hello there. Why Chris is embarrassing you?
Oh, well, it's a beginner's tutorial.
Well,
So, okay.
it will be crazy towards the end.
Yeah, feedback is nice to be controlled like this. So we can dynamically change it parameters, and yeah, we can create a lot of images like this. For example, yeah, my friend Sasha, she creates visuals with this, with like one shader and feedback with a lot of parameters, and it looks crazy. The most important thing about it is to make it less obvious, because here we can totally see it, but if you tweak it a bit, make it a bit more subtle, looks much better. So, yeah, I don't have that much examples, that many. Okay. The last one I've prepared is coloring a 3D model without any UV. Sometimes could be handy just to address the pixel position for coloring. For example, we don't have a proper UV model, proper UV with our model, or we're just coloring some, for example, silhouettes from Kinect. So here I'm using this pixel original position. It's not the projected one, but original, and I'm coloring it. So I'm sampling my texture without UV, but with the pixel position. And I'm using weird axis just to produce this nice effect on the model. So it looks, yeah, just to underline its volume. So same for 3D noise. Here I'm sampling from texture, but we can use any kind of 3D noise function to colorize our stuff like this.
A little note here, you can also generate your own 3D texture in DX11.
Yeah, of course. Yeah, but
with complete shaders. That's a different topic.
Yeah, it's a different topic. It wasn't that obvious for me that we can easily colorize our 3D geometry just without UV, just for its position, but actually it's very simple. Even for a beginner, we can use anything and colorize it like this, and just have a lot of interesting effects.
Actually, there's another technique which might help colorizing textures, well, models without UVs. It's called a triplanar projection, and it's basically deciding to which side you want to project your texture from based on the normal of your 3D model. Yeah, that's kind of advanced and tedious to demonstrate it here, probably. But yeah, there's a thing. So you don't necessarily need to use 3D textures to do seamless patterns of things.
Yeah, true. Well, also, yeah, cube map is handy, but.
Yeah, cube maps are also, again, a different set of topic, I guess. Also, what you can generate in vveekend, and also what you can generate directly with Compute Shader or with cameras. I mean, like an actual. So yeah, it's internally done and internally engineered to capture the scene, and then use that as a as a reflection cube map. I don't know if you cover this or not in this workshop.
No, I guess I'm out of material.
Sorry?
I guess I'm out of material, so yeah, it's only an hour.
Okay. I might also suggest to cover a little bit of under the hood things, like how temp targets work in DX11 and these sorts of jazz. Maybe?
Well, I would probably leave it to someone else because I'm afraid I can make a mistake. It will be stupid.
Aww.
Yeah. Well, I use those, of course, but...
Oh, well then, I might be able to demonstrate some of it. Let us see.
Yeah, thanks for help.
I will just clear up my clutter from my desktop. And maybe use our signal as a raw material. Just a second. And I have to. Oh, sorry. It's my monitor. Hello. A lot of stuff which I have to put this here. So under the hood, what you've seen in DX11, what Ekaterina was showing most of the time, it was called texture effects, which basically, for example, this is an anti-aliasing function. So the FXAA 1.1. This is a very, very complicated function published by NVIDIA, so we won't cover that. However, we will. This might not be the best example. It was just the first which was popping up on my screen. But if I find the final function, I won't find it. Anyhow, let's switch to some more basic thing like this. So here, as you can see, this is a wrapper around a temp target, a render target, on which you render two triangles, a full screen quad, and it's done for you. So you don't have to declare your vertex shader, for example, before your pixel shader, and you don't have to create separate nodes for your full screen and renderer and all sorts of options what you can have. But under the hood, it looks like this. So these in DX11, you have all sorts of special renderers here. What creates a window is the natural renderer, but for all kind of resources, all kind of type of resources, you have separate other ones. And the one which gives us a regular everyday 2D texture without any other bonus, like with the multiple render target renderer, which I don't think so we will cover it today. So this one, oh, actually we will cover that today because it's amazingly useful. So back to the topic. So what is the texture effects? And you have any shader file with just a single color in our case, and quad, and this is a full screen quad. And that is what you have in a texture effects. Now the problems come from using texture effects. Oh, it's a very, very, very convenient tool set, and it is also used in very much more complicated things like MSF, for example. It's used extensively. However, for for simple mixing, as you could saw in Ekaterina's example with blending together separate textures, you might also speed up the process using these layers. Maybe clone your shaders from constant, leave the vertex shader as it is, and then do whatever in pixel shader. Like, what should we do? Okay, we won't do anything here. Just imagine I've done something. And to be honest, I don't have anything prepared for this. Ekaterina was way much more prepared than me. And then, what else? I know, should we? Actually, I know, we will just blend together two textures. I know what does it looks like. That's cool. So we will blend together this one. Boom. And then like this with another one. And I have multiple images here. On this one. So as you can see, it will just override it. And we have quite handy nodes. I know this one actually is. So we have the quite handy node called blend. And this is, for some of you guys, this might be familiar from DirectX 9 ways of doing, but it's actually faster in DirectX 11 too, because you don't have to create separate render targets. But you can also create blendings like this. So, because you can instruct the video card that the layer is supposed to write is what kind of operation it should do on the pixel it is about to write to. I don't know if I'm clear or misleading or anything. So we can have the big epic image here. It is pixelated because also we have to define our resolution here, obviously. So, actually, yeah, you can hear me. That's for example one optimization you can apply, and obviously, if we look at Blend Advanced, so these simple nodes are just little presets for you, which is used most of the time, which are wrapping up a combination of these options. And to be honest with you, I'm not 100% sure what all of these exactly do, but this is the most convenient here. So you can even do subtract. So if I actually change up, change the order, so we are drawing the Weekend Workshop text after the trees, and set the Weekend Workshop here, and as you can see I can turn it on. Oh, okay, it didn't do what it was supposed to do. First of all, you can get like a minimum way here, minimum, maximum, and maybe if I do this, no. Oh yeah, it's a little bit of a trial and error as well. So then the source plan, it should be 1 maybe. Oh yeah, there you go. There you go. So the destination, you have to like consider the destination as well. So it is, you can do immensely complicated stuff with it. You can control how the input and how the output should be interpreted as well. I mean, inputs like the input of the pixel, of the original pixel, and the output like what the shader should write on that exact pixel. Yeah, I don't know where I wanted to go with this. Any clues? You have any comment on this, Ekaterina?
Well, yeah, maybe you would just wanted to show something with blending, because I showed only super basic stuff. Is it faster than using texture?
Yeah, well, it is faster if you want to blend together like, I don't know, 200 textures. It will be faster, but for in your case, when we were blending together two textures, or more specifically in this case, it is absolutely fine to use in shader operations, because first you will have way much more convenient and very much more comprehensible controls than what you have with render states. But also, you can do whatever you want basically. However, I think in DirectX 11.1 or DirectX 11.3, you can even read the previous pixel in pixel shader. Like if you load your resource as an unordered access view, you can absolutely do that, and you can also write to it, but you can't do it in DirectX 11.0, which is currently used in vvvv. And Vuk said that the reason why we only have DirectX 11.0 and not later updates is because SlimDX is not updated anymore. I guess it's not updated to those newer APIs. But he's working on one which on SharpDX, but that is a thing of the future. Also note that I might jump into a cool feature. So let me start that from an empty patch. Shall we? Because this is confusing. This can get confusing. What idea does this? So, for example, in your shader, when you want to use renderers instead of the texture effects, you also have the freedom to write. Actually, I will use this. To write to multiple render targets, to write to multiple shaders from a single set of pixel shaders. You can in DirectX 11 you can write up to 8 layers of 8 targets. However, Vux wouldn't recommend that, and he said I shouldn't recommend that either. Because it can actually slow your pixels, so it can cap your GPU's pixel filling as well. So you have to, for example, if you want to create 8 layers of like 8 layers of full HD resolution textures, all of them with 32-bit format. Oh yeah, we should cover that as well, shouldn't we? It's like you can actually change the format of your pixels. So they don't have. You can set the size of your individual pixels. I mean, not individual, but for a texture for every pixel. So in this case, it will just go crazy. You have to create 8 Full HD textures in like one frame, and it's not too good. So and obviously the stream processor, the pixel processor have to fill up 8 times 4 values, 8 times 4 floating point, 32-bit floating point values. It's very, very fast. So it's not recommended. However, we will do it just for fun, and not for 32-bit, but for normalized format. Actually, you know what? But first, before we do that, maybe I will demonstrate a little fact about these formats. What are these? Yeah, indeed. So like, let's have this plasma noise. And you notice the texture effects. And let's create. This is a simple operation. So this shader just you have a couple of scalars, you have a couple of numbers, and you do operations with the texture on those numbers. So that's what this shader does, and also output it. So if we look at the plasma noise, you don't have to look into this. This is just the random sine, cosine, whatnot, shade, whatnot noise function. But we are interested in this bit here. And as you can see, there's a string format. And here you can actually define your size of your pixel. So if I change this to R32 float, that means that our texture will only have one single channel, and that will be red. And if I save it, as you can notice, it will be displayed red, because all the remaining channels which are red throughout all the peep line is considered 0 when it is red on a higher component texture type. So this one in here, the texture 2D, it assumes that your texture is 4 component size, the 4 channel size, but you obviously don't output it here from the plasma. So to kind of solve that discrepancy, it will just fill up the missing channels with 0. That's why single channel textures are red. But notice also what will happen if I define it a second channel, so RB, nothing. I thought it would add, it would be more like red and green, so yellowish kind of thingy, but it turns out it does not. Anyway, so it does not work. You can't do this because GPU memory does not really work that way. So in GPU, everything is considered 4x4. So everything is kind of organized to be read in chunks of 4 or chunks of power of 2, because it is faster for the computer to deal with. So if I save this, then why I can't see this? Oh, something is bad here.
You should switch G and B because it's no, that's right. It's RBG not RGB.
Yes, I'm stupid. Sorry. In this case, there you go. So the two component works. Thanks for the notice. And now you can't do this. This is non-existent. Oh, actually, you can. I didn't know you can do this. Anyhow, probably it will just fills up the alpha. Okay, I'm pretty curious now. If the alpha will be 0. No, it won't. So it just fills up for you like that. And I might notice these numbers. What are these numbers here? These are actually the bits, and this is your type. So the this is how many bits you want to store per channel, and this is the format, the layout, or the type of the number you want to store. For example, so this is the finest. So the RGB32 floating point number, this is the finest and highest quality pixel you can get, and I will show you why. So if I make it very, very extreme power, like this, you won't notice any banding. So I can make it like that, and then multiply it down, maybe just like that, and yes, it won't have any banding present. If I change it to, maybe I can see if I raise it a little bit. I change it to 16-bit float. Well, you won't notice any much difference because 16-bit is still very fine. You can have like 65,500 something. I don't remember from head now. Maybe we can help with that. So. A single pixel will have 65,536 steps, but for 8-bit, and I have to change it to unorm because there's no 8-bit float in here. You can see immediately there's a very, very coarse, very, very harsh banding present. And that can actually mess up some of your effects. If you want to have a smoother view, you want to deal with 16-bit pixels. But however, this is for most applications, 8-bit 1 byte, so 8-bit pixels are pretty good. But just keep in mind that for 8-bit pixels, one channel can only have 256 steps compared to the 65,000 you can read it. So compared to this amount of steps, which is a huge loss in quality. That's in some extreme cases like this one here. And what else? Oh yeah, also if you're working with 16-bit pixels like this one, you can your values on the texture can go above 1 and below 0. And I will demonstrate that. Yep. So in here, in our plasma, I have little transformation which simply which simply transforms the values of the pixels. So I can actually hide everything. So see, it's completely black in the preview, and I can switch back here, and it's completely black here. But if I start to add back the same amount of here, as you can see, I can recover my texture. This is because on 16-bit floating point textures, I can go below, so I can write negative numbers. But there are a couple of effects and there are a couple of functions in HLSL which are not quite good with negative numbers, and that might give you artifacts. And you might, if you are working with this is called high dynamic range. This is called the HDR processing or HDR cross processing. So if you have that, you might want to check for negative values now and then, or negative values which might cause artifacts. So yeah, that's one note on the formats of your texture of your texture. And also another note on that is that you're not limited to unorm, which is 0 to 1, and that's, I don't know, sRGB variant, which I don't know what it is different from. Maybe it's important when you write out textures. But you can also write, for example, unsigned integer textures, which if you write that, you will not be able to preview it. So your graphics card won't be able to output it, for example, because your shaders have to know about the fact that those pixels are unsigned integers and not a normalized number or a floating point number. So, but applications for the unsigned integers usually are an advanced case when you want to have your objects to render out an ID, for example, an object ID, or some kind of jazz like that, and reading the back or viewing the back with a special shader written for that case is a little bit faster than writing floating points. And also the unsigned integers and the signed integer version exists because floating point textures or normalized textures usually could have rounding errors. So you won't get that with unsigned integer or signed integer when you want precise integers, because floating point can have like a little bit below, a little bit above, very, very, very slightly, but that slight difference is enough, for example, to mess up your equals condition in your shaders. So equals condition is like I don't know, A equals B. So that I'm talking about that. So rounding errors can, I don't know if the equals function here actually takes care of rounding errors or not. Maybe, I don't know. But yeah, that's a very special case. I can't demonstrate it now. I've used it only once in a project. I'm not really supposed to show you because that's like a commercial jazz. Back to this lovely renderer. So MRT is multiple render target, by the way. That's the abbreviation for. And here, if I just save this patch. Here. Which workshop is it? Is the 6? Yes. Oh, that's cool. And then clone or constant, and constant MRT. And yeah, it will be just cool. And here, in our pixel shader, you notice that a pixel shader returns a color most of the time. So it returns a vector, 4-component vector, which will represent RGB, obviously. But notice this also, it has a semantic. See, this is called the SV target. And that semantic tells the renderer or the raster, I don't know what is the stage called, which throws out, actually I can view that. So yeah, the renderer, it tells the renderer that this function will return the pixels. What this function returns, this should be it. However, this semantic is only an abbreviation, and I will show you why. So let's see if our pixel shader will not return a 4D vector, but it will return a structure. And in that case, I can create like one target. So I can define all my targets here, my desired targets here. So it's like color, and that will be SV targets 0. So this SV target here is actually a very dumb, well, not dumb, but a very, I don't know, simple abbreviation of SV target 0. Because I can define another texture here, and it will be like, I don't know, let's have this called 0 and call 1. And SV target 1. And yeah, let's buy 4. 2, 3. Okay, there you go. 2, 3. And our pixel shader should return this, that, and in our case, we have to initialize our output. So we initialize a structure, and o.call 0 will equal to this texture, and then like this. And then just for demonstration purposes, our remaining targets will be maybe the half, maybe the 3/4 of a previous one, like that, and this, and that. So what we do here is when we write to our target, we'll just use the previous target's value and then multiply it by 0.75, and this, in theory, this will give us a darker texture every on every target, and let's see if it compiles. It does not, because I don't need this and I don't need this. So in this case, and every of our targets, it should be this one. And if I connect a preview to it, this is not the right one. So the DX11 preview to it, in theory, it should. It shouldn't show up because I forgot to connect the geometry to it. There you go. Let's connect our plasma texture. Okay, the right plasma texture to it. I will just close this, not to get confused. And notice that from this renderer now, I have a spread of textures, 4 spread of textures. And here in the preview, if I get slice them, so in the preview there's a built-in get slice, by the way. If I get slice those, I am indeed receiving the darker versions of those textures. So I can write from a single pixel shader, we can write to multiple textures. And to also blow more mind, from a pixel shader, you can't only write to multiple targets, but you can also write to the depth of your renderer. So, and that is just as easy as it was defining our color in our output pixel. Well, in our output structure, I should define the depth, or this could be called anything. It could be called kitty cat as well, if you want to confuse people, but for convenience it will just be called depth. And that's simply, or the semantic which you should write to, it's simply called as vdepth. And I might write the out dot depth equals the red channel of our original texture. And in this case, I have to turn on depth here. So we have just a standard depth, and that is all right. More on that maybe later, maybe. And in this case, notice we can write to the depth of the render target, which is cool because I can use this value. For example, if I have a 3D scene in the same way, boom, actually I will put it within projection because I will use a camera. And a phone. With the box. And that one, let's have the build distance do. Notice that shaders which are not supporting the remaining render target will not write to the actual render target, so it will leave that alone. And or Phong directional will only write to wanted to say too quickly. It will only write to the first render target. So here, if I rotate my box around, as you can see, only parts of it are rendered because I'm writing the depth I'm writing to the depth from this pixel shader, and obviously our box will fail in cases when our depth value are lower than a box here. But then I can also change that. I don't know how many people I lost from this point. Actually, it's depth stencil. I can always, as you can. Okay, I won't actually use that. I will do a little. I will do a little transformation, but a little. What you call it, parametrization here. So it's like that offset and that move. Actually, that offset will be just fine. And then that offset. So in that case, you can see it here. And now I can cut my box like this, and then obviously I can also animate my original shader like that. So that will also work like this, and then rotate my box around. So as you can see, you have kind of total control over your targets here, and you can create interesting effects like this. And also, but however, I want to note that when you have a lot of computation to make, so your pixel shader is expensive, for example, if you define this, if you write to this semantic, your GPU will automatically decide that, oh, I should run this pixel shader before throwing it away to before the depth testing. So if I'm actually writing to this semantic, then okay. So first of all, when you depth test, when the objects are depth testing, the pixel shader, if the depth testing fails, the pixel shader won't run by default. If you define this depth, if you write this semantic, the SV depth semantic, your pixel shader will always run in the covered part of the screen. It will always run regardless, because it can alter the result of the depth testing. You can also change. I don't know if, for example, if I turn the order around, for example here, and to demonstrate that, I will do another funky jazz, and that's that stencil. So in this case, our background texture or the plasma texture are failing to, so this is not rendered where the cube is obviously visible, but the pixel shader of those pixels of the background texture is still run, because the GPU obviously have to decide based on this value whether the pixel will be rendered or not at all. And I can demonstrate that. So, for example, here, here with the depth stencil node, this node, we can actually also modify the behavior of how or depth comparison should affect or pixel filtering. So you can actually define a system where your depth is not compared to the most far object away has not the highest value but the lowest values. So you can do all sorts of jazz with it. Actually, then seal increment. Yeah. Okay. Where was? Let's equal it. Let's equal it right. I want to have. Anyhow. Okay, I might need to have an advanced here. Because I want to have the same results, but without the side effects what you could see there. The back phase comparison. Oh, okay. This is too much for this workshop, so we'll just get satisfied with this, I guess. Oh, maybe if I just do this. There you go. We have an actual render state for that. And this will write an exact value to our stencil. There you go. And now comes a little bit of jazz, which might be unusual for most of you guys, but with the depth buffer, we're not just getting a single depth value. We can also say that we will have a 24-bit normalized depth of the 32-bit depth part, and then an 8-bit unsigned integer stencil value. So this is crazy, but with this stencil value, so we can actually have two numbers extracted from our depth buffer. Obviously one of the depth, and other will be the stencil. And we can use this, for example, for testing, for filtering out pixels in our post process, filtering out pixels which are not written to in our original scene, which are, for example, empty in a 3D scene. So if I disconnect this and then have a stencil reference here, so if I write a constant value to this stencil from here, I can filter out only this cube. I can get the mask of this cube for completely free. I don't have to do a separate render target for that. And to get that value, actually I have this one. And this is interesting. There you go. It's much better. So we view that. As you can see, As you can see, there's the very weird combination of the plasma texture and our cube, and are also weird. You can create nice effects like this. And then if we view our stencil, which there's a node to extract that, it's called stencil view, or stencil view. I don't know if I'm pronouncing that good or not. Notice if I connect it to a third preview, I can see nothing. And the reason for that is that this stencil will be an unsigned integer texture. So as I told you previously, that unsigned integer textures will not render. The GPUs are not able to render that directly, so you have to write your own shader to deal with it. Thankfully, in MCROPEC there's one for you, and also in the girl power of DX11 there's one for you, which takes care of that. And in our case, it does not do anything. And that might be oh that might be a question why. Let us see. I actually haven't tried this node yet. Just Vooks told me that this exists and it should write a constant value to the stencil. But in that very case, we will try that on the box. So depth stencil, and let's read stencil increment. There you go. So here's our box there. Oh, it's very weird. It's actually written to when the depth test failed. I wonder why that is the case. To be honest, to my understanding, it shouldn't. We should see these carvings into the box in here as well. That is very strange. I know Vooks might have an explanation for that, but we don't have him around here. And let's see, that is very, very annoying. Actually, you can, as you can see, you can only render the object to your stencil buffer as well. So you have total control over it. It won't affect the depth buffer and your actual target. Oh, I know why it might. I know why it might not be tested like this, because it is writing to the remaining targets as well. So okay, let me just modify or phone diag. You know what? I will just do this. Let's see what's happening here. Boom, nothing. I'm forgetting something also. I will put this here. Box is there. This is there. That is absolutely there. Oh, I know why. I will create another technique which does not write to the depth. That's cool. That and let's have one other technique, which is like this, and then this, and That's okay. And then we have to switch to this. There you go. Nice and dandy. Well, yeah, the solution was not that it was writing. So that is awkward. I can't really tell you why these little carvings are not visible in stencil buffer. Anyhow, that is a very, very handy tool you can have there. For custom thingies. And as you can see, it writes to all of your textures. And yeah, guys, this is still tip of the iceberg, to be honest. So you can not only write to this, and you can not only write to multiple render targets from a single pixel shader, but there are other type of resources which can provide you even more freedom, like the texture array renderer, or for instance the volume renderer, and also, oh wow, what this, oh wow, okay, look at this, guys. What is this thing? I didn't know that this exists. Come on. This is amazing. And it has a button like that. And now it's gone. Alright. What is this? Where do I have it? Oh, plugins experimental. Okay, I'm using a newer build. Well, not a newer build actually. It's an older build because the newer build does not work. But it looks like that finally you have a renderer window. Which okay, it still blocks the vvvv. Anywho, might be the intentions that you could do this and then that. And it shows up as a different window. So finally, we have a window which is still blocking the interface. However, it shows up in a different scope as vvvv. Oh, it looks like you can even alt up to it. Well done, amazing, great job. That's very cool. If I write to it, I will use that all the time. So we can have get slice here. Sorry guys, I haven't noticed this, so I have to try it out right this time. So, okay, this is okay. Wow, nice. I even can remove the border. Look at that. Look at that. Amazing. And if I maximize it and then do remove borders, look at that. Full screen. Nice. Nice. Can you even set this? Now I can't do anything. Where is it? Topmost. Oh my god, this is so much cool. Alright. Oh look. And when I delete the nodes, the window's still here. You have to close it separately. So that's an experimental stuff. I bet books would say that do not use it yet. But yeah, I think you can use it. Anywho, back to our topic. So like, can only write to multiple render targets, but there's a resource type in DX 11 called texture array, for example, which can can represent you a stack of textures, and then you can sample them with a 3D coordinate, with a 3D texture coordinate, and the third component of that coordinate will be your targeting your layer of the texture. I won't demonstrate that for you now because I kinda have to go 1 hour later as well. So that might be covered in future workshops, like the one which is coming in before Christmas, for example, which will cover MSH as well, or more stuff will be covered next week. Not in pixel shaders, but in geometry, because next week will be, Everyone is Happy, or Kyle McLean will show us his instance noodles, for example. So, what else? What else with pixel shaders? Okay, I still have to show you one thing, which might be very, very, very useful in your project, and that can actually keep your shaders tidy. So, for instance, you have... How should I show this actually? I know. I will just show it with an example from MSH. And this one thing here is actually, this is a very, very simple task, this texture FX. It will visualize the metadata layers of MSH's output. But to have MSH working, or most of the textures in MSH working, look at this. You have to read 5 textures. Well, most of the time you read like 2 of them, but you have to connect to every effect in MSH 5 textures. Now, if you'd like to do that, for example, if I would copy this and have it in our, and remove these. These are spoiler alerts. And that. That would require you to connect every time this 5 texture here. That's nonsense, isn't it? So imagine that cobweb it would produce. So to avoid that, look at what happens here. There you can define your own semantics. And when you define your own semantics, if I save this, notice that it won't turn up as a node, but I can. Actually, I will demonstrate. Okay, so that was just for demonstrating the pin count. And I can actually say, demonstrate this. I will have a actually use a Nyanket. So that will be a semantic. This can be anything. If I save this, and notice that everything is gone here, so the texture pin is gone. But we have our node, not render semantic, and here we have render semantic direct texture layer texture 2D. If I connect this to another node, the semantics node here, you can define, and here I write Nyanket, connect this texture here. We can have our texture distributed like this. And it is very, very useful, because if you have like, I don't know, 16 layers which should use the same texture, all of them should use the same texture or the same resource. It is not limited to textures. you can actually define any type. Like you can define 2D vector, any type of vector. This is just a 4D vector represented as color, an integer, a structured buffer, for example. I can't see a row buffer, but it should be insanely easy to write one. Any number or transformation. So if you have 16 layers, which all use this number, you don't have to connect to each pin individually. You can just create one render semantic, and instead of connecting that into this node, I can, if you look here in the inspector of group, there are 2 hidden pins. I can connect it to the node like this. So everything which is connected to this group will receive this semantic like this. So that is mind-blowing, isn't it? So yeah, as you can see, our cube is now receiving the same texture as well. So this is a very good demonstration. Now you can see there. So our cube receives the same texture as well, because the cube is the same, is rendered with the same shader, but without connecting the actual texture to the shader, so to the shader node. So in that case, you can do, yeah, it just makes your life very easy when you have a complex scene. And you might also do your custom renderer. In practice, this is, for example, used in Emeshe to propagate the previous view matrix and the previous projection matrix, for example, and also the other metadata which will be covered later on in the Emeshe workshop. So yeah, that is one useful thing. And did you got anything in mind as well for final thoughts on Ekaterina?
Well, not really.
Actually, do you have a nickname? Because Ekaterina seems a little bit long to just...
Yeah, you should just call me Kate, it's okay.
What was that? I didn't hear it.
Kate. Like
Kate? Okay.
Yeah, Kate is okay.
That's cool. I didn't know that's a nickname for Ekaterina. Cool.
Oh, it's the same, yeah.
It's the same. Okay. It's okay.
It's short name. Yeah, short name.
All right. So yeah, the last thing I would show you guys is also very useful. So here, if you wanted to have a variation of your shader, you have to, like before, you had to create a completely different technique for that, and that might cause you code duplication. What you can see here. So our only difference here in this shader is that in the second function, we don't want to write to death. So instead of me defining a completely different technique and duplicating my own code, and I can do the following. I can use something called preprocessors, and preprocessors are little commands for the compiler what to do with the incoming text of the shader code before of compilation, and you can actually use those. So I can say if define and write depth and this block here, and this block here will only be present if I do something like define write depth 1. And this, remember, this is a preprocessor, so you can actually define numbers like this, but that will, for the compiler, that will look like and the actual text. I don't know if I'm clear about this one. But I don't want to do this because I want to set this condition for every individual shaders. Because if I do this, I would shed for all the shader, all the instances of this shader. So I'm not defining that here, and also because I'm reading this value, I have to also put this part into an if defined. And I can then actually repeat string, and I can then create these defines in vvvv in a pattern like this: write depth equals 1, which is very strange because it's not really how you define it here, but anyhow it will check for the equal sign. And I can put it here. I can put it there. So if I save this and then constant, so look that obviously or plasma or background did not stop to render because define the write depth is not defined there. So if I turn that back on, I can now dynamically switch. I can now dynamically modify my shader with like predefined segments here inside vvvv. So you can have, this means in short technical terms, you can have your own defines driven from vvvv. Or basically, in more technical terms, vvvv just attach we will just attach before it comes to before it is fed to the compiler. We will just attach a define something 1 in the beginning of the shader text or the effect file. So that's how you can, for example, avoid techniques for all of your combinations. And yeah, other technique is actually using classes, for example, and interfaces. But there, I will just show you that. So the color channel remap is a very, very good example of that. This shader, if we go here and raise the saturation of this, so this shader does only, it only redirects, it is kind of a matrix redirection of the channels. So you can choose that, okay, the red channel should be read from for example, the saturation, and then the green channel should be read from the blue channel, and then the blue channel should be read from the red channel, and either the alpha should be still be alpha, for example, if we want to keep that. And then if I go this, then you can have a very strange effect, and you might also cause very strange effect with this if you use it with feedback, as you could see in Kate's sessions, in Kate's section. In this shader, what happens? Why do you have these individual enumerations? You only used to have that in technical, but now you can have it here. It's because you can define your interface like this iChannel interface, which is basically a bare bone to classes in programming languages term. It's a bare bone of classes. It defines a type of class and all the classes which inherit from this interface. This is how you inherit from something in a class. So all the classes which inherit from this interface should also always contain this function, so this channel. And as you can see in my classes here, I can define what this function does per class, but it should always contain the class function with the same name. As you can see here, it can have it here. So we'll just return 1, return 0. And then when I have that, I can define a global variable which has the type of that class, okay, and which will be used by the shader program. And this one, the iChannel, the input thread, this will be used to select one of these like that. So it will start link class, and then you can so these will be the variables which you link to the individual items of the enumeration here. And then in your shader, you will actually this one is used for the shader. So then in your shader, you will call these. It's not easy to comprehend, but it's very, when you understand it, it becomes very useful. You can call these and execute that function. Whatever it does, it will be that. And the result of that function will depend on which class you select for that interface, for that global variable interface here. I don't know. Was it understandable? Maybe? I don't know. You understood it?
Yeah, I'm okay.
That's all right. So yeah, that's, I think this is how much we can call this a day. So this is how much we could cover in pixel shaders. There are some couple other extras when you want to deal with pixel shader in texture arrays. In that case, you have to define a thing called what you call it? Maybe it's a SV slice or layer or something. I'm not. Let me Google that. Oh, okay. Actually, let me Google that. SV layer. Not Slayer. Oh, come on. SV layer. Microsoft. Microsoft. Okay, I won't find it. So you have to define the semantic from the geometry shader to tell that which slice you want, which texture slice you want to render to in your pixel shader. So that's very, very advanced stuff. I won't really deal with that. And I don't know. We might have a compute shader workshop at some point, but I haven't arranged any yet. Maybe in the future. Maybe Kyle McLean will talk some stuff about those. So yeah. Do you have anything else to show us, Kate?
Yeah, no.
Actually, someone asked object-oriented programming in shaders, and answer is kind of. It is not that object-oriented. You can't create like new object and then instantiate objects. You can't do that. It is very bare bone. What you can do here, what you can do is actually you can group together functions and members. You can actually create classes. Okay, another way, you can create static classes in shaders, but not public or dynamic classes. You can't instantiate them dynamically. You can only instantiate them like this. Like you can create static instances of those. Maybe. Constant error. And then here in pixel shader there is a use, for example here there's a use whether it would for clamping, because it writes the UV coordinates to the output. Oh, actually, yeah, it is instantiated. One instance is created only. Yeah. Okay, so that's cool. This is the same. This is actually the same as you can find it here. So yeah, that's the answer for that comment. All right. In this case, I would call this a day. Before we say goodbye, I would also tell some news as well. So this was the last workshop which was aired from vvorkshop, because the vvorkshop office will cease to exist, but the company won't, so we will still be alive, but in like not in a physical space. And so that will come. I don't know, I have to solve that, because at my home the internet connection is not too good. So for the next week I will find out something. And also other news, next week will be about instant noodles. I just said it for the last time, so I won't really mention that. Okay, yeah, instant noodles actually. That is this guy, everyone is happy, or in its real name, Kyle McLean's contribution, and that's a very handy collection of very simple tools for geometry, which might ease patchers in creating and dealing with geometry or during the day. And that will be the third section on the visual series. And the fourth one will be on the following week. That will be about MSR, and I don't know much about that yet. I know much about it, but I won't tell you. So that's it. That's the news. So goodbye, guys. Thank you for joining us. Thank you for the pixel shading introduction, Kate. So,
thank you for help.
And let's see. Okay, I actually closed the signal. So bye, guys. See you on next weekend. Bye. Where should I turn this off? Oh yeah, there you go.